Okay, shall we start? Great. Thank you for being here on the almost last session of this PyCon. So yes, my name is Stavros. I'm an ML engineer. I'm working in SafeSize, and for this session, I'm also wearing the hat of MLflow ambassador. The material of this talk, source code, and also the slides will be on my GitHub after this session. So what are we going to see today? So this session is built up slide by slide. So we'll start with the motivation of this talk. We will see what's behind of to keep our models fresh in real-time environments without downtime. So we'll see why inference in serverless. We'll give around to learn what is the machine learning ML life cycle and some things about MLflow, which is the main technology of the whole, let's say, architecture. We will see what is Amazon Lambda and how we will be using this. And of course, the main context of this session, the hot swapping, and the last round of a live demo. So let's go. Great. So what's behind the, let's say, updating models in production? So we know that no matter how well machine learning models are trained, over the time they can suffer from model drift and also data drift. And as new data are coming, we can encounter some changes in our let's say predictions or recommendations or whatever our models does. So it's very, let's say, crucial to adapt whatever changes are happening in real-time environments. So let's say when we update our models, this can cause a downtime in our application, and this is when we are interested in environments that are, let's say, sensitive, let's say time sensitive, where let's say downtime is crucial. So this let's say when we're going to apply dynamic updates, it also helps, let's say, to speed up the entire machine learning life cycle. And also, it also helps us to, let's say, avoid of rebuild and restart the entire application. So what's behind the hot swapping idea? It's that we have an event, let's say, driven architecture. So our models are going to be updated when some kind of event happens, and we are going to replace the current model that there is in production with a newer model. So the way that we are going to do this is complete, let's say, Pythonic. I'm not going to tell you now. You might gonna guess it by now, but I will leave you with a cliffhanger. So about, let's say, machine learning inference. Anyone here who is not, let's say, familiar with what inference is? Okay, awesome. So yeah, serverless can be, let's say, somehow, let's say it can be a confusing term, but there is still server. But we don't care about how is managed. So we only, let's say, we are focused on how we implement this inference logic in production. And also another, let's say, advantage of it is that we have zero overhead. We don't need to, let's say, think about the API. We only, let's say, focus how our inference logic will look like. It's integrates seamlessly. We don't need to do, let's say, something that, let's say, it concerns with the managed service or the API, as we said. So it also allows for faster, let's say, experimentation. We just commit, rebuild, and the Lambda, let's say, code automatically updates. The only thing that we should look at when we, let's say, work with Lambda is that we can, let's say, we should rebuild our Docker image, which hosts the main Lambda logic. And also we should look at the cold starts of the Lambda. We will see later what this means. So let's have a look on the machine learning lifecycle. Anyone here who is not familiar with what the ML lifecycle is? Awesome. So I think that I can skip that, but anyway, the main topic of it is that we use MLflow to, let's say, manage the entire life cycle from data logging, experiment and model logging up to, let's say, model deployment. So some sort of text about MLflow. Anyone that already uses MLflow? So no one uses MLflow. So you do the life cycle without MLflow. Okay, awesome. So, okay, MLflow is an open source platform able to assist machine learning professionals and teams to handle, let's say, complex or more simple machine learning applications. So MLflow focuses on the full life cycle and actually ensures that each phase is manageable, it's traceable, and can be reproducible. So we can implement the whole life cycle. We can have AI governance of our models and experiments of everything. And also it can help to bridge the gap between experimentation and production. And also it can reduce the friction between the teams, as the ownership always stays in the data science team. So if you don't use MLflow, you should definitely do it, even for your, let's say, pet projects. It offers a great documentation. It covers a handful of case studies. And of course, you can also come in touch with a community in Slack channel. So, yeah, I forgot that I have steps here. So anyway, let's go forward. So what about Amazon Lambdas? Anyone that uses Amazon Lambdas? Awesome. 1, 2, the lights, 3, 4, 5. Okay, awesome. Okay, so Amazon Lambdas are dead simple, actually. You have only a, let's say, main function that actually plays a role of what is served. So this is the handler, and everything that is that is around the handler takes place of the entire execution environment. So when we spin up our lambdas for the first time, or even if the lambda is become cold after some period of time, the first thing that runs is everything that is outside the lambda. So for this case, let's say that we just load our models, and when the lambda is warm, everything that runs when we, let's say, execute an API call and ask for a result only happens in the invocation part. So the question is, how do we leverage the lambda with the Pythonic way in order to, let's say, update the model while it's still warm? So the difference with, let's say, a system that does not run in the lambda is, let's say, for example, an EC2 instance, is that when we have a new model, we should restart the whole service. So the catch here is, how do we still give, let's say, recommendations in our system, and we can also update the model without restart the whole service? Or alternatively, how do we still keep the lambda, let's say, warm? So, okay, hot swapping. We will have a quick look on the architecture behind this. So yes, so it's quite simple actually. When we train our models, we make sure that everything is run out there in an MLflow environment, and we track our models and experiments in the MLflow server. So we just run our models. MLflow offers a very fluent Python API with very little overhead, actually, almost to zero overhead. So when, let's say, that our training run time is completed, then we should serialize our models in an external, let's say, storage system. For this topic, we will use S3 buckets in Amazon. So the idea is that after we train, we use the MLflow client to take all the information of the MLflow server, and we serialize our models in a, let's say, dict-like structure, in a JSON-like structure, you name it. And after this, it means that we already have deployed our Lambda. So Lambda is already there. And when Lambda starts, it's going to load the serialized structure from S3 directly in its content. So Lambda will be up, and up to this point where our service is up, we're going to, let's say, experiment and see from our client here that, okay, we can get some results, and what happens next if we retrain the model and when we update again the file structure in S3. So yes, this is where all the magic happens, actually. This is the logic that exists inside the Lambda. So the refresh model function handles the loading of the models from S3. So we use a global variable, the model list, to store the loaded models in memory. So this we will make sure that this variable will keep living for all the entire runtime of the Lambda. So this code, as we said before, is defined outside of the main function. And by the time it's up, it loads the serialized model from S3. So when we detect a newer model, we check, let's say, given a time scheduler that we have set it up, and let's say we are aligned in the team that we want to update our models per based time schedule. I mean, per hour, per, I don't know, 6 hours, whatever. For the sake of this demo, we will set it for 1 minute in order to have, let's say, fast updates. So the rest are, I think, are very simple. So we replace we also check if the version of the newer model is different, and then we replace the model. So I think that it's time for a live demo. Okay, I will need my both hands. Okay, and also I need to turn my head. So okay, this is the training script we will use just for this demo. Very simple dataset of the iris dataset, and we are going to train a linear regression. So let's say that the task here is just a linear recommendation of what the flower is. So yes, let's give it a spin. So awesome, our model is trained. It is logged in our central, let's say, management system. So let's move forward to the serialization logic. So what happens when we serialize the model? Give me a sec. Okay. So this is the main point, that we use the MLflow client, as I said before, to fetch all the information from the central MLflow server. So in this case, our model is named Iris model. So we go through all the models, all the registered models, and we take the version, the model name version, and anything that is related with our task. So this is the part that we actually serialize the model in a dict-like structure. And the logic here is how we leverage Boto3 in order to register or upload or write or whatever this structure in an S3 bucket. So it's very simple. We have our function here. It is just how we open a session to S3 bucket and actually register our artifact. So let's move on how the Lambda looks like. As I said before, all the logic that lives outside the main function is related to load the let's say, artifacts. And this is where the magic happens, where we refresh the model. We set the 1 minute time schedule. We read the model from the structure, and this is the handler that actually gets the model and does a prediction. So moving forward, we will, let's say, start our client that sends a request every 1 second. Okay, our Lambda is up. We get, let's say, the recommendations. Our current model version is 4. If you remember, we already trained the model. It went on the next version, model 5. Now we are gonna do the registration or the serialization. And up to this point, we're rewriting the structure on the S3 bucket. So it's uploaded, and we have to see in like a minute how much time we need. 40 seconds. Yes. So in 40 seconds, we should be able to see the model version to be, let's say, proceeded in version 5. So remember, at this point, Lambda is still running. We are not doing anything with the service in Amazon. And when the time schedule, let's say, is enabled, at this point, we should be able to see the next model version. Okay, happened. Awesome. Great. So yes, that was it. Thank you so much.